And speaking of grabbing rocks, our next speaker, Julie Mitchell, will be talking about how we updates on how we're going to curate those samples when we bring them back. Julie, please take it away.
Thanks, Deborah. Can you hear me?
Loud and clear, thank you.
Awesome, thank you. I'm Julie Mitchell. I'm the Artemis Curation Lead, and I'm going to give you hopefully a pretty quick update on what's going on for Artemis Curation, starting with a little bit of background info. Next slide, please. So the goals of Artemis Curation very broadly are listed here. The first goal is to preserve the Artemis samples. We definitely want to make sure that the samples are not altered in any way, or at least any alteration is minimized after collection and when we're curating them in the labs here on Earth. We also want to provide initial sample characterization and catalog development, which we call preliminary examination, to help enable scientific studies of the samples that we're bringing back. And then we also want to enable those scientific investigations using both current and future technologies via long-term sample storage and distribution. This is something that has been done very well for the Apollo samples, and anyone who's aware of the Apollo Next Generation Sample Analysis Program, or ANCSA program, will see the value of well-curated samples. Next slide, please. So you've heard about the Artemis Science Definition Team report quite a bit today. Dr. Renee Weber did a great job of summarizing that and leading that effort. So I'm not going to talk about the background of the report too much, but I am going to pick out a few of the findings from that report as I go through my presentation to emphasize the very curation-specific findings that are most relevant to us. So the first is the finding you see here, that Artemis should collect a diverse set of sample types. And the reason this is important for curation is that we need to make sure we are capable of and prepared for preserving those diverse types of samples. So I'll talk about the types of samples in a couple of slides. But we also want to make sure that sample collection and in situ measurement are complementary, and so we should do both of those. And the reason I bring this one up is that in situ measurement is very important, especially when we start talking about volatiles. We want to make sure we have some idea of the types of volatiles we'll be collecting, because depending on what volatiles are there, that has some pretty big impacts on how we're going to collect the samples and curate them once they come back. Finally, the last finding I'll mention here is the cross-directorate integration efforts. This is something you've been hearing about all day today, but it's especially important for curation because while we are implementing the curatorial effort to facilitate science through SMD and for the scientific community, we are working with HEO, of course, because HEO will be collecting and returning the samples, and with STMD for our technology development efforts, in addition to interfacing with the various communities outside of NASA. Next slide, please. So obviously we've heard about HLS a lot. You heard about this from Jake Bleacher earlier. The specifics of how much sample we'll be able to bring back really depends on the final HLS results. And so I'm quoting the requirements here, but I want folks to be aware that the down mass for samples isn't just for geology samples. It also includes biology samples, which have been mentioned previously, human health samples, the containers that the samples will be in. And so it will be very important for us to understand what the down mass is so we can refine our efforts and plans for how we're going to curate the samples. The notional sample types are listed at the bottom right of this slide. I believe Renee had a much more detailed version of this chart, but the reason I bring this up again is just to make sure we are prepared in the curation office at JSC to curate these samples, whatever form they may be in, whether they're small class, large class, core samples, and so on. Next slide, please. You just heard about the tools, so I won't go into this in a lot of detail, but this is obviously a very, very distilled down version of what Adam covered earlier. But I want folks to be aware that the curation office is working quite heavily with the engineers. We have a great working relationship, and we're talking through science requirements and contamination control virtually daily. And so we are very interested and involved in this process as the engineers go through their design and certification efforts. Next slide, please. Contamination is a big deal as well. You've heard a little bit about contamination previously, and this is something that, of course, is very relevant to curation. Obviously, in flight, we want to mitigate contamination, but once the samples get back, we want to make sure that we keep the samples as pristine as possible. And so I have listed here the different types of contamination. Those three bright blue boxes at the bottom there, those are the volatile specific types of contamination that we are really doing a lot of technology development on. Also, contamination knowledge is very important, and we will be pursuing this throughout our entire curatorial effort as well. Next slide. So now I'm going to focus on volatile samples quite a bit. A lot of challenges there, of course, in terms of hermetically sealed samples and so on. Next slide. So as you've heard before, cold stowage is a top priority effort for Artemis. It's being worked by all of the different NASA mission directorates. So I'm going to spend the next few slides talking a little bit more about what we in the Curation Office are doing, specifically in regards to volatile samples and cold samples. Next slide. So there is some prior experience in terms of returning cold samples. We've flown freezers on the ISS and the space shuttle. We have experience there. And in terms of cold and cryogenic sample storage on Earth, the microbiology community has some experience there, along with the ice core community. And so you can see the Venn diagram there in the middle of the picture shows the overlapping requirements that we have to consider for preserving a cold sample. Next slide, please. So this is our lab at JSC, and I wanted folks to see this because we have made some really great strides here in the recent past, and we'll continue to do so in the future. We are really working on our ability to handle and process and store for the long term volatile rich and cold samples. And so we have an entire laboratory that's dedicated to this effort. We have a chamber that's replicating the lunar pressure and temperature environment, and that's shown here on the left. On the right, you can see we have a brand new negative pressure glove box. If you're familiar with how we curate most samples under positive pressure to prevent contamination. In this case, because we are doing some preliminary efforts with some volatiles that we don't want to be inhaling while we're in the lab, for safety reasons, we are working at negative pressure. For the actual samples, we would want to have some combination of positive pressure with negative pressure inside to protect the people outside the glove box, the curators and sample processors, in addition to preserving and mitigating any contamination of the samples inside the glove box. Next slide, please. So another couple of things from the Artemis SDT report. Of course, we want to have a fair and open and impartial sample request and allocation system. The heritage from CAPTEM was mentioned in the document. Now we have the new XMAG and AARB, which are fulfilling the roles that CAPTEM previously covered under one organization. And so we have a very good relationship with XMAG, and we have been in discussions with the Lunar Sample Subcommittee on making sure that we continue the legacy for our previous sample collections that has worked so well. Also, the SDT report mentioned next generation laboratory analysis. This is a really big one, and I invite folks to go take a look at the whole report, of course, but especially this part. I had to cut this down a bit. Really what I'm highlighting here is state-of-the-art curation techniques, but there's a lot of other things in here that require some state-of-the-art advancement as well. And so we are working towards developing those state-of-the-art curation techniques, especially for volatiles, but also using new technologies that have been developed since Apollo as well. Next slide. So talking about sample characterization and cataloging, this is what I mentioned before as preliminary examination. So next slide, please. So when I say PE, I'm talking about that sample characterization cataloging. And so for rock and particle samples, this typically follows a process of documenting the sample by taking photographs, quantifying the amount of sample by weighing it, classifying the sample by roughly looking at rock type and things like that, and then providing a sample identification number or subsample number to that material. For a volatile sample, we're going to have a different paradigm. And I'm about to run out of time, so I'm not going to go through these in detail, but this is in particular something that we are talking with the XMAG folks about, and we want to make sure that we have a very well-established and robust process for doing preliminary examination on the volatile samples when they come back. Next slide, please. And long-term sample storage, of course, this is incredibly important. As I mentioned before, the success of the ANGSA program really shows how well and how important long-term sample storage is. And so we want to make sure we do this for Artemis as well. And so we're preparing for both ambient temperature and cold and cryogenic sample storage and processing. At JSC right now, we are still working on where exactly the samples will be stored, but we're looking at multiple different options, including new versus current facilities. And once we make that decision, of course, the community, all of you will be notified of that. And that's my last slide. Thank you.
Thank you so much, Julie, for that excellent summary on curation. Lots of exciting developments there.